The next case we want to look at is what your textbook refers to as the type 2 binary compounds that contain metals. In this case, we're going to have ions that do not have a charge in the list of common charges that we looked at earlier in this chapter. So we are going to need to be able to communicate what that charge is in the compound and predict what that charge is when looking at a formula. To predict what a charge is, we're looking at ions that do not have a common charge, such as many of the transition metals like iron, cobalt, manganese, nickel, copper. In fact, many of these form more than one ion, so that's why we don't have a common charge that we memorize. To figure out the charge, we have to work backwards from the formula and determine the charge. And because there's just no way from looking at the periodic table to know what the charge is, we have to communicate in the name what the charge of the ion is going to be. To do this, we've got to remember that the overall charge of the compound is always going to be 0. These are neutral compounds. When you put a compound together, you have an equal number of positive and negative charges. And we can use that fact in the charges we know to determine the charge of the metal. So take the anion charges that you know and then use that to determine the charge of the metal. Now, for example, let's say we had a pretty straightforward case, CuCl2. I know I've got copper and I have 2 chlorines, and I know the total must be neutral. I know chlorine is -1. There are 2 of them for a total of -2. Which means the total of the coppers has to be +2 to balance out. And since there's only 1 copper, copper here would be +2. So I know I'm dealing with the copper 2+ and the chlorine 1-. So being able to figure out what that charge has to be will allow us to write a name that will tell everyone what that charge is. When you have a metal that doesn't have a common charge in the name, what we do is write a Roman numeral. That Roman numeral tells us the charge of the metal. So in our CuCl2 case, we knew it was copper with a 2+ charge, so our name will be copper, Roman numeral 2, chloride. We still do the IDE ending at the end. So it's the same as our previous type of naming, except now we're including a Roman numeral, and that Roman numeral tells us the charge of the copper. A common mistake is people think that that Roman numeral tells us how many coppers we have. That is not true. It is the charge of the copper. Just to remind you, the common Roman numerals: 1 is I, 2 II, 3 III, 4 IV, 5 V, 6 VI, 7 VII, 8 VIII, 9 IX, and 10 X. Generally, we're going to have charges less than 5 or less, so you'll generally just use the first couple of Roman numerals that you probably know from earlier lessons. So here we have a bunch of formulas and we want to write the names. FeCl2. I know it's going to be iron, chloride. Now I know chlorine is -1. There are 2 of them. So iron must be +2. The next one, FeCl3. Once again, iron chloride. You can see here where if we just wrote iron chloride, how would you have any idea which one of these 2 formulas you were dealing with? In this case, we know chlorine, there are 3 -1s, so iron must be +3. So 1, 2, 3+. This next one, Sn, tin. Sulfur, sulfide. Sulfur is -2. There are 2 of them. So tin, to balance that out, must be +4. So tin, 4, sulfide. Cu2O. Now this is an easy one to make a mistake on. You have 2 Cus, 1 O. So this kind of chart sometimes helps a lot. I know oxygen's -2. I know the total is 0, so the total here must be +2. There are 2 of them, so each one must be +1. So Cu, copper 1 oxide. Pb 3N2, so I've got 3 Pb's, 2 N's. I'm looking for the charge of each of these. I know nitrogen's -3. There are 2 of them for a total of -6. The total for the compound must be 0. So lead must be +6. There are 3 of them. So each lead would have to be +2. So lead 2 nitride. This last case, we have silver. There are 3 of them. We have phosphate, so we don't change the ending because it's a polyatomic. Phosphate's -3, so each silver would be +1, but silver is always +1, so we wouldn't include a Roman numeral here, so it'd just be silver phosphate. Now, let's go from the names to the formulas. Iron, Roman numeral 2 chloride. I know iron must be +2 here. Chlorine is -1, so FeCl2. Lead 2 oxide, Pb2 plus, oxygen 2 minus, PbO. Lead 4 phosphide, Pb4 plus, phosphorus is 3 minus. That ID ending tells us it's an element. Pb3P4. Copper 2 acetate, Cu2 plus, CH3COO minus. So Cu, CH3COO, 2. Titanium, 2 selenides. So selenium, -3, Ti3Se2. Cobalt 3 chromate, cobalt 3 plus, chromate CrO4 2 minus, CO2 CrO4 3. Vanadium 5 plus, nitrogen 3 minus, B3N5. That ID ending told me it was nitrogen, not nitrite or nitrate. Platinum, PT 2 plus, sulfur 2 minus, PTS. So here we have metals that we do not know a common charge for, so we use a Roman numeral, and the Roman numeral stands for the charge of the metal.